the second video in this unit, we are going to take a look at how we can actually utilize the information about our subatomic particles to characterize the atoms. So last time we did talk about those characteristics. So why is all of this information so important to us? Well, what it does for us is it allows us to determine certain characteristics a particular atom or a particular element has. Now we can use the periodic table to help with some of those, whereas the others are very simple math. We're talking addition and subtraction here. So the first one that we want to go through is atomic number. This is the same as the number of protons a particular atom has, and we can easily determine this using the periodic table. So if you actually go and you take a look at your periodic table that you were given, look at the legend or the key, and it will actually point out to you the atomic number. The atomic number is always a whole number with no positive or negative sign in front of it. It's never a decimal either. We can't have a partial number of protons. So using the periodic table allows us to find this number of protons in a very easy and convenient way. All atoms of a particular element have the same number of protons and therefore the same atomic number. So if I have something that has 2 protons, an atomic number of 2, it's always going to be helium. If something has an atomic number of 10, if you find that on your periodic table, that's neon. And all atoms of neon will have 10 protons. If I have 9 protons, I have fluorine, and if I have 11 protons, I have potassium, or sodium. The second characteristic we're going to look at is atomic mass. This is determined by the mass of the nucleus because our electrons have so little mass that we ignore it completely. So we can say that our mass is the number of protons plus the number of neutrons. And we can actually write that this way. Okay, so our mass equals the number of protons, P plus stands for protons, plus the number of neutrons, N0 stands for neutrons. And again, you're going to get a whole number because I can't have a partial of either of those. This is going to give you, therefore, then a whole number. So let's work through an example here. What is the mass of an element that has 20 protons and 17 neutrons? And what element is it? So let's deal with the first part, the mass of an element that has 20 protons and 17 neutrons. Keeping in mind that we said that mass is equal to the number of protons plus the number of neutrons. So if we're determining the mass, based on the problem, the number of protons is 20 plus 17, which gives us a mass of 37. The second question says, what element is that? So what we would do with this is we would actually go on our periodic table and look up the 20 protons. 20 protons tells us that the element is calcium. Okay, so that's 20 protons. And we can use our periodic table to determine that. Okay, however, if I have that element or that atom of calcium having a mass of 37, not all of my atoms of calcium are going to have that mass. Okay, so in order to be the same element, they have to have the same number of protons. But what can change that gives us that different mass is the number of neutrons. What we do is when we have the same atoms of the same element with the same number of protons but different masses because of different numbers of neutrons, they are called isotopes. Now let's run through an example of an element with some isotopes, and that is hydrogen. If I have hydrogen with a nucleus that has only 1 proton and no neutrons, my mass is going to be 1. If I take that same element of hydrogen, I still only have 1 proton, but this time I have 1 neutron. My mass is 2. And my third isotope gives me 1 proton, still hydrogen, still atomic number of 1, and 2 neutrons with a mass of 3. Now, take a look at the mass of hydrogen on your periodic table. It's a decimal, and it's 1.00, and then there's a bunch of numbers after the decimal. But if you look at the numbers we calculated here, these are all whole numbers. But when you check on the periodic table, we have decimal numbers. So why do we have decimals there? That's because the periodic table are decimals because they are averages of the masses. Now, going back to my example of hydrogen, this actually gets a little bit confusing, because if I take my mass of 1 plus my mass of 2 plus my mass of 3, I get a total of 6. Now, to find the average, I take 6 divided by 3, because I had 3 units there, so my average should be 2. But if you look at the periodic table, my average is 1. What happens here, this isn't just a normal average, this is actually a special average. Kind of like how your tests or how your grade is calculated, where your tests and your quizzes count more, 80% of your grade, than your homework does at 20%. Basically, we look at how much of each type of element are available. And in this case, I have a lot more of hydrogen with a mass of 1 than I do the other two. So my average atomic mass for that is closer to the 1 than it is to the 2 or the 3. We are not going to get into how we calculate that because it's not that complicated, but it's not important at this time, and you'll actually learn about that in chemistry, the full chemistry course that you take later on in your high school career. The last characteristic we want to look at is atomic charge. Atomic charge is important because our atoms can be either neutral or they can have an electrical charge, either positive or negative. This is determined by the number of protons and electrons that are present. So to determine the charge, you take the number of protons and subtract the number of electrons. So in other words, charge equals the number of protons minus the number of electrons. When you write the charge, you do have to indicate the positive or negative. It's not like math when you subtract two positive numbers. You don't have to write the positive there. You do have to write it when it's negative. In this case, you have to write it either way. Okay, let's look at a couple of examples. An atom has 16 protons and 18 electrons. So I take protons minus electrons, and my charge is -2. If I have an atom that has 14 protons and 12 electrons, when I subtract those, I get a charge of +2. And that's a great example of where you have to have the positive, the plus sign, listed. The last example is where I have 2 protons and 2 electrons. And in this case, when I do the subtraction, I get a charge of 0. In other words, that means my atom is neutral. So, we've talked about atomic number, atomic mass, and atomic charge. Scientists like to be able to reference this and represent this information in a very quick and easy way, and we're able to do that. Okay, because all of this information actually tells us a lot about the elements that we are working with. So, we have created a shorthand that is called nuclear notation that allows us to do so. So, let me show you an example of a nuclear notation and kind of explain its parts. Okay, so this is what the setup looks like. This top number here, the 23, represents the mass. The bottom number represents the atomic number, or the number of protons. And this number here, if it is there, represents the charge. If there is no number there, then the charge is 0. Sometimes with charge, we actually don't have the number 1 there, and that's fine. We can do that as well. We can also represent this using what we call an isotope symbol, and that is representing using the name of the element as well as its mass. For example, uranium-242 tells us that we have uranium with a mass of 242 AMUs. So now that we understand this nuclear notation and about our subatomic particles, what I want to do is I want to actually take you through the atomic structure handout together so that we can fill it in. All right, I have left off the column headers for this, but going across you have atomic number, atomic mass, atomic charge. So we have atomic number, atomic mass, we have our charge, we have our protons, neutrons, and electrons. Now, let's start filling in row 1. If I look at the nuclear notation here, the bottom number represents atomic number. So my atomic number for this one is 1. The top number represents my atomic mass. So that is 1. If I look to the upper right, we have no number there, so that tells me that my charge is 0. So now using this information, I can then therefore go and determine the number of protons, neutrons, and electrons in this atom. The number of protons is going to be the same as my atomic number, which will be 1. Now, if you remember, protons and neutrons contribute to mass, and we had said that mass is equal to our proton number plus our neutron number. Now, in this case, though, I am solving for neutrons. So let's rearrange this, and my number of neutrons is going to be equal to my mass minus the number of protons. So, if I look here, I've got my mass of 1, and my number of protons is 1, so 1 minus 1 gives me 0. That leaves me with my number of electrons. Electrons and protons are involved in charge. Charge equals the number of protons minus the number of electrons. So I can rearrange that to solve for electrons. And what I get is the number of electrons is equal to the number of protons minus the charge. So in the one that we are doing, my charge, or my number of protons is again 1, my charge is 0, so the number of electrons I have to have is 1. Now let's do the second one. Atomic number is 1, my mass is 1, and this time my charge is a plus 1. The number of protons again is going to be 1. 1 minus 1 gives me again neutrons of 0. Now looking at the charge, I now have a charge. So protons, which is 1, minus my charge, which is 1. 1 minus a positive 1 gives me a 0 here. All right, let me fill in the third line here and see how you do. All right, so my atomic number is the bottom number, which is 12. Atomic mass is 6, which atomic mass is the top number, which is 12. And since I have nothing in the upper right, the atomic charge is 0. Atomic number and number of protons is the same. Mass minus protons, so 12 minus 6 gives me my number of protons is 6. And then protons minus the charge, 6 minus 0 gives me 6 for my electrons. Now for my lithium, Li, bottom number is 3, atomic mass is 7, charge is plus 1. Atomic number and protons is the same, so that has to be 3. Number of neutrons is 7 minus 3, which gives me 4. And my charge and my protons determine number of electrons. 3 minus a positive 1 gives me 2. The next one here is a little bit tricky. I have atomic number of 17, mass of 35, charge of negative 1. Nothing changes here. 17 for protons. 35 minus 17 gives me 18 neutrons, but this is where we have to be careful. For my charge, 17 minus a negative 1. If I take 17 minus a negative 1, that is the same as saying 17 plus 1, which is 18. That is the number of electrons that I have. You do have to be careful with that. The last one in the top half then is 19, 39, and 0, and then 19, 20, and 19. What I would like for you to do is to pause the video at this point and try the second half of the worksheet on your own, and then you can come back and check your answers. What I'm going to be doing is actually writing up on the top here those formulas again. Okay, so neutrons equals mass minus protons, and electrons equals protons minus charge. Atomic number, atomic mass, our charge, protons, neutrons, and electrons. All right, so now you've got the lower half. And I'm going to fill it in. (33, 42, and 36. 47, 108, 0, 47, 61, 47. 47, 108, plus 1, 47, 61, 46. 16, 32, negative 2, 16, 16, 18. 92, 238, and 0, 92, 146, and 92. So hopefully you did well, and that will allow you then to complete the parts of an atom worksheet then for homework. One thing I did want to point out is with the nuclear notation, I'm going to use this uranium here as an example. If for some reason I didn't have that there, you can't assume that it's 0. We can never have a number of protons as 0. But what you can do is actually look that element up, U, on the periodic table, and you would see that it is element number 92. So you could use that information to determine your number of protons as well. So in the next video, what we will be doing is we will be actually going over the homework worksheet, parts of an atom.